Snowflake. Welcome to the course. My name is Naveen. I have 10 years of experience in data warehousing. And if you are brand new to Snowflake, you are in for a treat. Snowflake is an absolute joy to work with. And if you are willing, I will teach you everything I know through this course. Here's the course index. Through this course, you will understand Snowflake's unique features, its architecture, and what makes it a modern data warehouse. We will start with a tour. We will log into Snowflake and we will tour the user interface and its various features. Then we will go through the basics of cloud data warehouse and how it is different from traditional on-premise data warehouse. What is SaaS and how it is different from regular software. We will see the differences between Snowflake and big data. And we will also go through the differences between Snowflake and Teradata. We will talk about various Snowflake features and Snowflake architecture in detail through this course. Okay, so you're excited to learn about Snowflake. Before we get into the concepts, let us take a quick tour of the Snowflake user interface. Snowflake officially provides two ways to connect to Snowflake data warehouse. First, you can use the Snowflake web user interface, or you can use the NoSQL client. So since Snowflake also supports the standard ODBC connections, you can use your favorite SQL client to connect to Snowflake. But official tools are the Snowflake web user interface and the NoSQL client. So let's take a quick look at the Snowflake web user interface. So once your company signs up with Snowflake, you get a unique URL for your company. So if you look at the URL, the first word in your URL is the account number, followed by the zone in which Snowflake has been installed, and just your regular login prompt. So you can use your username and password to log into Snowflake. And once you log into Snowflake, you get a nice minimalistic user interface, nothing fancy. So you have your, right now I am in the worksheets tab. So inside the worksheets tab, there are multiple worksheets. Worksheet is nothing but a place where you can type in your SQL queries. The nice thing about this worksheet is as you type, it gets saved. So you'll not lose any queries if you close this browser window accidentally. So you can add as many worksheets as you want, and you can close them or drop them whenever you don't need them. So that's with the worksheet. And you have this database explorer. You can just collapse or expand them. So in Snowflake, we have this database, and inside the database, we have a schema. And inside the schema, we have multiple tables. Okay. We can select a query and we can hit the run button. We get our query results in the results pane. We get our query metrics like how long did it take to complete and all that here. And we get the actual output in this pane. And we also have a button here to see the query history. So we can click on it to see the entire history of the queries run. Move to the right, we have this context pane. So this is where you choose the role, you choose the virtual warehouse, you choose the database, and you choose the schema which you want to query. Let me try to show that to you. So right now I'm in the sysadmin role. We can change to any other role if you want to. So most developers will have this public role. And right now we have two virtual warehouses. I have a reporting warehouse which is extra small, and I have a compute warehouse which is extra large. So let's go with the extra small instance. And I can also choose the database name, which database I want to query, and I can also choose the schema. So if you look at here, right now my extra small instance is in suspend state. If I execute any queries, it will resume. But if you want to manually resume, I can do it by clicking on this little button. That's all with the worksheets tab. And if you look at here, this tiny dot here, so it's grayed out, which means that the instant is in my virtual warehouse is in suspended mode. So when I execute any query, it will turn into green. Say, for example, if I run a select star query, if you look at this little dot now, it's in green now. So which means my warehouse has been started and it has executed this query, and right now it is in running state. So that's all with the worksheets tab. And let me move to the database tab. The database tab is where you can create a new database. So you can go ahead and create a new database. You don't have to specify any space limits, as it comes with unlimited space and compute. So you can create a new database here, as well as you can provide grants to the database. You can provide grants to other users using this side panel. Use this clone to create a new copy of this database. And the best thing is it doesn't copy the data, all the data. It only copies pointers to the data. So you can also drop a database here, and you can also transfer the ownership from one role to another using this option. And that's all with the database tab. And we have this shares. So this is something about data sharing. If your data provider is on the cloud, is on Snowflake, and if he's willing to share data with you, you can opt in for Snowflake data sharing. Without any ETL, you can just go ahead and use the data. Warehouses tab. This is where we create and manage all our virtual warehouses. So right now I have two virtual warehouses, the compute warehouse and a reporting warehouse. A reporting warehouse is an extra small and compute warehouse is an extra large instance. And both are not in running state right now. Okay, I can create a new virtual warehouse here. So I can just give the name. I can choose the warehouse size that I want, from extra small to 4x large. Extra small has one server, and small instance has two server, and so on till a 4x large server has 4x large virtual warehouse has 128 servers in it. So the best option is to choose a small warehouse size and gradually increase it to fit your needs. So you can also specify the time, idle time, after which it will automatically suspend the instance, the virtual warehouse. Manually suspend or resume a virtual warehouse here, as well as you can drop a virtual warehouse if you don't want it anymore. And you can transfer ownership from one role to another using this portal here. And then our good old worksheets tab, which we have already seen. Followed by the history tab. The history tab is where you see the history of all the queries executed by you, as well as other users if you have the sufficient privileges. If you notice, you also see a query ID here. Query ID is a unique identifier for each SQL query executed in Snowflake. Regardless of you executing the SQL in the web-based UI or executing it in SnowSQL or executing in Tableau, each query executed gets a unique query ID. And if you click on that query ID, you can see the full query ID here. So the query, if you have any support needs, or if you have to talk to Snowflake support, or if you have to talk to the support person in your company, you can use this query ID as a reference. You can just pass this query ID and they will be able to view the query on their side. And there is also a query profile. If you look at here, if you click on it, you get a nice graph on all the steps involved in executing that query. So for any serious query, you'll get a nice graph. Since our query is a simple count star, I just get a two-step process. And you also see the metrics associated with the query, like the IO, the scans progress, the scan progress, the byte scan, the total number of GB scanned, and all those metrics. And this is a nice helpful tool for doing any performance tuning, as well as troubleshooting any performance issues with your queries. So that's all we have with the Snowflake user interface. And apart from this, I have a few more icons. This is some of the partners available with Snowflake. And we have the help section here, and our regular user administration section. It's a nice minimalistic user interface. Cloud data warehousing is huge. Of course, we have Snowflake. You also have alternatives like Amazon Redshift, Google BigQuery. What makes Snowflake unique, apart from its simplicity, is the learning resources. Snowflake has an extensive documentation. This would be your go-to resource for any reference. And Snowflake also has a very helpful and active community. And of course, our own copy coding community with a ton of educational content on cloud data warehousing and Snowflake. Before we dive deep into the course, let us start with the basics. What is cloud data warehousing and how is it different from the traditional on-premise data warehouse? So in a typical cloud data warehouse, the hardware, the software, the network infrastructure, everything is maintained by the cloud vendor. Even the software patches are being done by the software vendor. Whereas in a traditional data warehouse, you need to host the software, the required hardware, and the network infrastructure. Everything has to be built in-house, and it needs to be maintained by by a team of engineers on site. The major difference between the cloud as well as the on-prem data warehouse is the scalability. With the cloud, you get unlimited compute and unlimited storage resources. Whereas in on-prem, you have a fixed set of compute and a limited storage available. So this also means that if you have peak loads during month end or during holidays, you can even double your compute resources and get the work done in half the time. And also, you do not have to do any capacity planning while doing any new projects. It just comes with unlimited capacity. The second advantage is pay-per-use. So with the cloud, you only pay for the active usage. When you do not need those resources anymore, you can just suspend the resources, and you will only pay for the active usage. And you can even shut down the cloud resources during the night time, and you could save on the cost. Whereas in a traditional data warehouse, regardless of you use it or not, you have to pay for it. And then less maintenance overhead. So with the cloud, the hardware, the OS patches, as well as the application software patches, and the network is being maintained by the cloud vendor. Whereas in an on-prem solution, we need to take care of all the patches and everything by ourselves. Starting with the cloud data warehouse is very easy. So for example, if you have to start with Snowflake, it's just a couple of clicks. You can literally get started in less than 30 minutes. You can start with a small compute resource, and then you can expand it till petabytes. Whereas in a traditional on-prem solution, say for example, if you have to bring in Teradata data warehouse, it takes months. So you have to sign up contracts, you have to do capacity planning, you have to identify your compute needs, and then they ship the hardware and software to your premise, and you have to mount them and do all the networking and all that stuff. So cloud data warehousing has very little capital cost to start with, as well as it also provides a frictionless start. And last but not the least is the security and encryption. So with the dedicated team, the cloud data warehouse providers offer various security certifications like HIPAA, like SOC compliance. They take care of all the security and also the encryption needs of the data. So considering all these, moving from your on-prem solution to a cloud data warehouse is a no-brainer. I hope you agree with me. Snowflake is offered as SaaS. SaaS stands for Software as a Service, which is nothing but a hosted software where we pay based on the usage. We could be doing a fixed plan like a monthly or an annual plan, or it could be a variable subscription like usage-based subscription. Few examples of SaaS software are our Gmail mail client, the enterprise messaging software Slack, even Office 365. They're all hosted softwares. In a typical SaaS model, both the hosting as well as the software upgrades are being taken care by the vendor itself. Along with that, the vendor also takes care of the security needs, the scalability needs of the application, as well as the encryption needs of the application. So to summarize, in a SaaS model, we just sign up and we just start using it. The vendor takes care of all the hardware, software, the backend needs. Visit copycoding.com for more learning resources on cloud data warehousing as well as Snowflake. First things first, let us prepare the environment for our Snowflake training. Let's start by creating a virtual warehouse. A virtual warehouse is a collection of compute resources. We need a virtual warehouse to query data from Snowflake as well as to load data into Snowflake. So a virtual warehouse is a collection of CPUs and its own allocated memory. So let us go ahead and create a virtual warehouse. Okay, now I have created a training virtual warehouse, which is extra small in size, and I have specified an idle timeout of 60 seconds, which means if it's idle for 60 seconds, it's going to be suspended automatically. And I have, and if an user executes a query, it is going to resume on its own without having to manually start the virtual warehouse. And these are a few other settings with the idle timeouts. So now let us go and verify whether our virtual warehouse has been created successfully. You can go to the warehouses tab, and if you notice here, our warehouse has been created. You can alternatively use the user interface as well to create a virtual warehouse, and you could achieve the same results. So now we have our virtual warehouse. Let's go ahead and create a database. So since we have multiple users in the system, let us create a database with our username in it. Okay, now I have created a database. Let me go to the databases tab and then verify if it's there. Okay, here you can see, and let me go back to the worksheets tab. And every time after you create a warehouse or after you create a database, make sure you set the context appropriately. So right now I'm in sysadmin role. I'm using training warehouse, which is good. And right now I'm in the sales database. So now let's go ahead and create a schema. Inside a database, we can create multiple schemas, and each schema can have its own tables and its own views. So let us create a schema for data, schema for views, and a schema for stage. Okay, now we have created a schema. Use this context menu to change the virtual warehouse, database, and then the schema. Alternately, we can also use SQL commands to navigate to the correct warehouse and correct database and schema. So if you look at here, I want to use the training warehouse, virtual warehouse, and I want to use the database sales Naveen DB, and I want to use the schema sales data. So since we are using the web interface, we have the option to change the virtual warehouse, database, and schema using the context menu. But if you are using the SnowSQL, which is a command line utility, it doesn't have any UI. It is just command line prompts. You could use these handy commands to use the proper virtual warehouse and proper database and schema to execute your SQL queries. And at any point in time, to make sure that you're in the right database and schema and using the right virtual warehouse, you could use this command. If you fire this command, it will tell you the current database name, schema name, and the virtual warehouse name. There are multiple editions of Snowflake. Right now, we are using the standard edition of Snowflake. In standard edition of Snowflake, the auto scaling is not available. So that is the reason we have not used the auto scaling parameters in our virtual warehouse while creating the virtual warehouse. But if you are using an enterprise edition of Snowflake, you will have a few more options while creating a virtual warehouse, like specifying the auto scaling, the initial cluster size, and the maximum cluster size, and all that. Quick recap: we have started by creating a virtual warehouse, and we created a database, and then we created multiple schemas. So this information and public schema are the default schemas that comes with any database. If you create any database, you will get these two schemas by default. We created the warehouse, database, and schema using SQL commands. We can also do the same using the user interface as well. So that brings us to the end. We have successfully created the environment for our Snowflake training. Snowflake is the data warehouse built for the cloud. What does it mean to be a data warehouse that's built for the cloud? Snowflake uses traditional ANSI SQL, which means all your developers can easily switch over to Snowflake with little training. And all your existing applications and reports can be modified to run out of Snowflake. Snowflake has no management overheads. There are no primary indexes to create. There are no data distribution keys to maintain. There are no partitions. Encryption is enabled by default. Compression is enabled by default. So you simply load data into Snowflake and start using it. Snowflake takes care of everything behind the scenes. Snowflake supports both structured as well as semi-structured data. It is always good to have the ability to combine both structured and semi-structured data in our reports. And Snowflake promises concurrency. Literally, we could have all our users run queries against Snowflake and never have performance issues. Since Snowflake is on the cloud, we only pay for what we use. We don't have to run Snowflake 24/7 like our traditional data warehouse. We just run Snowflake whenever we have some active workloads, and we only pay for what you use, and we don't have to pay for any idle time. Snowflake leverages all the good things about the cloud, like unlimited compute and unlimited storage. So when we have active workloads, like month-end loads or during any holiday rush, we could literally double our hardware capacity, compute capacity, and get the work done in half the time. And while starting any new projects, we don't have to do any capacity planning really. We will start with 0, and we could grow till petabytes of storage. Snowflake offers a very frictionless startup. You could easily sign up for a Snowflake account with a couple of clicks, and in less than half an hour, you'll have a fully fledged data warehouse up and running. How is Snowflake different? Let's talk about MPP, Massive Parallel Processing Systems. In a true MPP, say for example, if you have 10 nodes in a cluster, the data will be evenly distributed across all the 10 nodes, and if the user fires a query, all the 10 nodes work in parallel, and then they return the results to the user faster. Snowflake is a true MPP system, whereas Hadoop or Big Data is not an MPP system. Secondly, Snowflake uses plain ANSI SQL, whereas Hadoop or Big Data needs specialized skills. The developers need programming skills like Java to write a MapReduce program, and they also need to have some Unix expertise to handle the files and all that. Thirdly, Snowflake is very reliable. Gartner research found that only 15% of big data implementations are successful in production. Snowflake is very simple to use and it's very reliable, and it could scale up to petabytes of storage. How is Snowflake different from Teradata? Let's talk about the similarities first. Both Teradata as well as Snowflake are massive parallel processing systems. Both Teradata and Snowflake use plain ANSI SQL. Both Teradata and Snowflake use their own patented proprietary technology on how it works behind the scenes. And both Teradata and Snowflake has proven their ability to handle huge volumes of data. Let's go to the differences. When you purchase Teradata, they literally ship the hardware and software to your on-premise. You will have to mount them, network them, and then have them maintained with the set of network engineers. Whereas Snowflake is a cloud-native data warehouse solution. With just a couple of clicks, you could get started with Snowflake. Teradata also offers a cloud version, but the on-premise version is the popular one with Teradata. Teradata has its own proprietary hardware and software, whereas Snowflake uses AWS or Azure cloud services and its own proprietary layer to which acts as the SQL engine. Teradata ships with a fixed capacity. If you need to expand, you'll have to sign up new contracts, and then you have to increase the size of the hardware as well as storage. Whereas Snowflake, since it's on the cloud, it comes with unlimited compute and storage. Snowflake stores the data encrypted by default, whereas Teradata doesn't claim any default encryption. But I guess they should have some form of encryption as well. In Teradata, we have a common compute system, which is shared between the data loading as well as data retrieval. Whereas in Snowflake, we could use a virtual warehouse for loading data into Snowflake, as well as we could use an independent isolated virtual warehouse for querying data from Snowflake, which is very efficient because we don't have any resource constraints between the reporting teams versus the development teams. Teradata is always on. Snowflake, since it's on the cloud, we just pay for what we use. If we don't have any active workloads, we can suspend the virtual warehouses, and we don't have to pay for the idle time. And of course, the cost. Snowflake claims that they are much cheaper than Teradata. When it comes to performance, Snowflake effortlessly matches or performs even better than Teradata queries. In an independent research performed by GigaOM, they have ranked Snowflake as the leader. They have tested different data warehouse platforms available, and they have concluded that Snowflake is the best data warehousing platform. Why Snowflake? Maintenance. Snowflake literally has no maintenance needs. There are no primary keys, there are no indexes, there are no collect stats or any other type of table tuning that is needed in Snowflake. You simply create a table, start loading data, and for better, you don't need the infrastructure team and DBAs to maintain Snowflake. Snowflake takes care of everything behind the scenes. They do all the vacuuming and cleaning and tuning needed for your table to work. And the second one is simplicity. Snowflake is very simple and it's very intuitive. If you already know SQL, there is a very tiny learning curve, and from the developer's perspective, nothing has changed. They can easily switch over to Snowflake with little training. And since Snowflake supports standard ANSI SQL, most of your existing reports should work with Snowflake without any issues. And Snowflake comes with unlimited capacity, which means you don't have to do any capacity planning before starting any projects. You just simply get started. And Snowflake also comes with unlimited compute. In Snowflake, each team can have their own virtual warehouse, and each virtual warehouse can auto scale based on the loads. So when you have huge workloads, you could literally double your compute cluster, and you could get the work done faster. Snowflake simply charms with its simplicity. Compression is enabled by default. Encryption is enabled by default. Even Amazon or Snowflake can't read your data, and there is no maintenance needs. Like we don't have to bother with indexes, collect stats, primary keys, and all that. In fact, they are not even available in Snowflake. You simply load the data, and Snowflake just works without having to do any of this geeky stuff. And Snowflake is a columnar database, which is good because if your table has a zillion columns and if your report has only cares about 5 of those columns, it will perform very good with Snowflake. And zero copy cloning is one of the major features of Snowflake, which means if your testing or if your development teams need a copy of production for their development or testing needs, you could just use zero copy cloning, and without actually copying the physical data, it just copies the pointers to data, and you have a new copy. Visit copycoding.com for more learning resources on cloud data warehousing as well as Snowflake. SnowSQL is a command line interface, which means you have to open up your command line terminal. There is no user interface, and you just have to type in your SQL commands. Apart from SnowSQL, you also have the official Snowflake web user interface, which you can use to log in and do all the SQL operations. SnowSQL is a very powerful utility. It lets you to interact with data, create tables, views, and other SQL operations. You can even unload data from Snowflake. You can use it to load data into Snowflake. Not to mention your ETL tool uses SnowSQL under the covers to load data into Snowflake. So let us go ahead and install. Once you log in into your web user interface, click on the help icon and hit download. I'm going to go ahead and download the Windows version. Let's go ahead and install it. Hit next. I'm using the default options and hit install. Okay, it got completed. I have opened the run prompt now in Windows, and once you are in the run prompt, type cmd. It opens up a terminal, and inside the terminal just type SnowSQL to start the program. For the first time, it's going to check for the latest updates, and it is going to push all those updates. Now the installation is complete. Let us go ahead and check the SnowSQL version by typing in snowsql-v. Okay, we are on version 1.1.71. Let us go ahead and connect to Snowflake. So to connect to Snowflake, you need to type in snowsql-a followed by your account number, and followed by -u, and then your username. I'm just going to copy paste this. Once you enter the command, it will prompt for your password. And once you enter your password, we are now logged in. If you notice, you see my username followed by a pound, and then the virtual warehouse that we are using currently, and no database and no schema has been set up now. So let us go ahead and set the context. We could use the use commands to change to the proper virtual warehouse, proper database, and schema. Let us use the training warehouse. I'm just copying the use warehouse training warehouse command. So right now, if you notice here, we are right now in the training warehouse. Earlier we were in the compute warehouse. Let us go ahead and change the database as well. So let us use the Snowflake sample data. Okay, now we are in Snowflake sample data. This is the database, and let's choose the schema as well. So let's use the schema, the Snowflake performance testing schema, and hit enter. So right now, if you notice, we are using the training virtual warehouse, and we are using the Snowflake sample data database, and then the performance testing schema. So to make sure you're on the right database and schema and warehouse, you could always run this command. You can run select current database, current schema, and current warehouse. It's going to return you which warehouse you are currently on, to make sure we are querying against the right database. So now that we have logged into SnowSQL and set the context appropriately, let us go ahead and query a table. So we have a table called the call center table. Let us try to see the number of rows in the top 10 rows in the table. Okay, so it's not very friendly to the eye, but I got the top 10 rows from the table. So you could type in your SQL commands and get the results here. You could use it for DML as well as TTL operations. You could use SnowSQL for loading data as well as retrieving data from Snowflake. And let me talk about the help. So there are these exclamation commands. If you type exclamation help, it's going to give you the list of help commands, which you could use inside the command prompt. And once you're done with the tool, to quit Snowflake, just type in exclamation and quit. And we are done. We have installed SnowSQL, and we logged into SnowSQL by typing in the account name and username and password. And once we logged into SnowSQL, we set the DB context to the right virtual warehouse, to the right database and schema, and we executed a select query, and we quit the SnowSQL. It is a hassle to type the username, password, account name, and to set the DB context every time you log into Snowflake. So there is a workaround for that. We could use the config file, and we could type in all the connection parameters inside the config file, and we could use the config file to log into Snowflake. Let me show you how. Okay, here's my config file. I'm using a Windows-based PC, so my config file is in C drive, inside users folder, inside my username. There is a folder called .snowsql. Inside the folder, we have our config file. Let me open the config file. Okay, this is how my config file looks like. And if you scroll down to the connections section, this is where we define the connection. My connection name is called as training, and my account name, and this is my username, and this of course is a dummy password, and the database name, the warehouse name, and the schema name. So I have given all the connection parameters here. I can use this config file to log into SnowSQL now. Now I can use the config file to connect to Snowflake. I'm typing in SnowSQL -c, and our connection name is training. Okay, if you notice, it didn't ask for the username or password. It just used the username and password from the config file, and it set the warehouse, the database, and schema on its own without having us to do this manually. And if you notice here, the prompt itself is taking half the screen, which makes it very uncomfortable for me to type my SQL queries. There is a way to customize this prompt to make it more minimalistic. All you have to do is type in exclamation set followed by the prompt format. I want to set my prompt format to double greater than. Okay, now my prompt is done. So I can type in my queries here. And if you notice, we got rid of that ugly prompt, and we got a nice minimalistic prompt. So the set prompt that I defined before, it is applicable only for this session. If I log out and log in again, it is going to be back to normal. Okay, if you want this double greater than prompt permanently, you can again open the config file, go to the options section, and type in the prompt format and save, and you should be done. So now you'll have a beautiful prompt whenever you log into SnowSQL, and you don't have to type in your username and password as well.